Hello and welcome back to PA Academy. So this is a continuation on our lecture series on superposition theorems. So if you missed the previous part, kindly check the playlist. You'll find a link to some of those videos. So now let's look at this example. So here we are having a circuit and it says find the current in branch AB using superposition theorem. So that means in this particular branch AB, we should look for the current that is flowing through it, and we are asked to use superposition theorem. So if you look at the question closely, basically what they're asking us to calculate is the current that is actually flowing through this 30 ohm resistor. Because if you look at it closely, the current that is flowing through AB is also equals to the current that is flowing through the 30 ohms resistor. Exactly. So because here we are just having a voltage source. Are we good? So you need to also take note of that and look closely to questions when you are trying to attempt them. Okay, so now just like I explained at the beginning, that when you are dealing with superposition theorem, if you look at this question now, we are having two voltage source. Exactly. And based on what I've explained earlier on superposition, I say you are going to consider one voltage source at a time. Exactly. So what I want to do now, let's duplicate this. So I haven't done that. Now let's consider just the 30 volt source. So let's start with that. So if we are considering the 30 volt source, that means this 20 volts, we can just take it out and replace it with a short circuit. Exactly, because it's a voltage source. So we replace it with a short circuit. So that will no longer be there. So now let me write it here, that considering the 30 volts source. So that's what. So don't forget, once we are done analyzing this, we are also going to consider the second voltage source, which is the 20. Exactly. So now let's take this place to be, let's assume the current flowing here. So let me change my pen color. So let's take this to be our I1. So I want to use mesh analysis to simplify the circuit. So let's give it some polarities based on the direction of current that that's I1. So it will be plus, minus. This will be plus, minus. So this will be plus, minus. Don't forget there's a resistor here. Plus, minus, plus, minus, plus, minus. Very good. Okay. So now let's apply KVL. To mesh 1. So this is our mesh 1. Let's take this to be our mesh 1. This is our mesh 2. Okay. Alright, so for our mesh 1 now. So before we proceed, let's just take notes. This is 10. So 10 ohms, 10 ohms. So just take note of that. Alright, so now let's continue. Let's apply our KVL to mesh 1. So in doing that, we are going to be having, so from positive to negative due to current I1, so that will be minus 10 I1. Then the 30, this is our plus, this is our minus. Remember that the polarity for the voltage source is constant. Based on the longer side is positive, the shorter side is negative. So from negative to positive, though, that will be plus 30. So coming over here, plus to negative due to I1, so that will be minus 20 I1. So if you come over here, from plus to minus due to I1, so that will be minus 30 I1. And then we are having negative to positive due to I2, so that will be plus. So this is I2, 30 I2, and that's in for that close part equals to 0. So if we should tidy this up, we are having minus 10 I1, minus 20 I1, minus 30 I1. So together we are having minus 60 I1, so plus 30 I2. So plus 30 I2 equals to, so this 30, if you should come, this 30, if you should come the other side of the equals to sign, we are having minus 30. So this is our equation 1. So let me continue here. So if we say apply, so apply KVL to mesh 2. Okay. So for the mesh 2, so let me just bring the circuit down a bit. So let me just put the circuit side by side so that you can see it easily. Okay. So now we are considering mesh 2, which is this part here. So let's just start from here. So you can just start from anywhere. So from positive to negative due to I2, so that will be minus 30 I2. Also from negative to positive due to I1, so that will be plus 30 I1. So now let's come over here. So from positive to negative, so that will be minus 10 I2. And then from positive to negative, minus 30 I2. Then equals to 0. So if you should tidy this up, let's see how many I1, we're having just this 30 I1, so that will be having 30 I1, then minus 30 I2, minus 10 I2, minus 30 I2, so that will give us minus 70. Minus 70 I2 equals to 0. So this will be our equation 2. Exactly. So now we can go ahead and solve our equation 1 and equation 2 simultaneously. So solving equation 1 and 2 simultaneously. So again, let me write out the equation 1. So this is the equation 1, minus 60 I1. So minus 60 I1 plus 30 I2 equals to minus 30. And then 30 I1 minus 70 I2 equals to 0. So if you do that, you are going to be getting your I1 to be equals to 0.64 amperes, and then your I2 will be equals to 0.27 amperes. Now, in the first example I did, I actually showed the working for the simultaneous equation, but just to save time, I'm just using my calculator. But please, when you are doing this in exam or test or in class, make sure you actually solve it out. Don't just use calculator to jump at your answer. Exactly. All right. So the next thing is that now that we've gotten the value of I1 and I2, and don't forget I said it at the beginning that we are asked to calculate the current that is flowing through. So let me draw it here. Yeah, if you go back to the question, we are asked to calculate the current through this branch AB, and I've explained it here that the current flowing through this branch AB is the same thing as current flowing through the 30 ohm resistor. So with that, now let's use it to analyze what we have here, so that we can know the exact current, because we're having I1 and I2. And if you are to draw that branch where we have the 30 ohms, exactly. So based on the direction that we have, that's okay, that I1 is flowing in this direction and this is I2. So we can conclude that I2 is upward direction and I1 is downward direction. Exactly, because if you should continue like this, you can see it will face downward. If this continue like this, it will face the upward direction. So that's how the direction is being determined. So how do we now know the exact one that is flowing if this is I1 and this is I2? So we've gotten our I1, we've gotten our I2. So how do we know what exactly is flowing there? So like I said, for you to get it, you look at the two value I1, I2. So I1 is higher than I2. So as you can see here, so the one that is higher, so that means the current that is flowing through AB, which is also the same thing as current flowing through the 30 ohm resistor, will be I1 minus I2. Exactly, because the value of I1 is higher than I2. 0.6 is higher than 0.27. Exactly. So if you should do that, that will give us 0.6 minus 0.27, and that will give us 0.37 amperes. So again, the direction will be what? The direction of the one having the higher value, which is I1. So our I1 is facing the downward direction. So let's indicate it. Are we good? So now we are done with the first step of answering the question when we are considering the which voltage source did we start with? So when we are considering the 30 volts source. Exactly. So now what we are going to do again now is we are going to withdraw the circuit. Exactly. This time around we are going to be considering the 20 volts. So let me copy this. Okay, so just take note of this because we are going to be coming back for it. Alright, so this is the initial circuit. Now we want to consider this. So for us to consider this, that means this other voltage source, we are going to short circuit it. Exactly. So that means we are going, let's just represent that with a line. Okay, so now let's start again the process considering the 20 volt source. So if you are finding value in this video, please give it a thumbs up. So now let's pick polarity for, remember I'll be using mesh analysis, and like I said, you can use mesh analysis, node analysis, whatever method you are comfortable with. You will just be surprised that you get the same answer. Alright, so this is, let's say the current here is I1 and this is I2. So based on the direction of current, let's pick our polarity. So this will be plus, minus, plus, minus, plus, minus. So for that of the voltage source is always constant. So this will be plus and minus. So now let's come back to I2. So this will be plus, minus, plus, minus, plus, minus. Are we good? So let's just put it here that apply KVL to mesh 1 or loop 1. So let me call this my mesh 1 and let me call this my mesh 2. Okay, so if you should do this now, so let's start from here. So from positive to negative, so that will be minus 10 I1. So from positive to negative also, that will be minus 20 I1. So from positive to negative, that will be minus 30 I1. And then from negative to positive due to I2, so that will be plus 30 I2. And then the voltage source from positive to negative, so this will be minus 20 equals to 0. Okay, so if you should tidy this up, we are having minus 10 I1, minus 20 I1, minus 30 I1. So if you should add those three up, we are going to be getting minus 60 I1. Then I2, that will be plus 30 I2 equals to 20. So let's note this as our equation 1. Okay, so now let's go to, so let's apply KVL to mesh 2. Are we good? So in doing that, so this is our, what we are considering as our mesh 2. So where do we start from? So let's just start with, so let's just start from here. So from positive to negative due to I2, so that will be minus 30 I2. So from negative to positive due to I1, so that will be plus 30 I1. So we'll move over here from positive to negative, so that will be minus 10 I2. And for this, we'll be having minus 30 I2. So then this is from negative to positive. Then that will be plus 20. So this will not be plus 20 I2. Don't make that mistake because it's the voltage source. Exactly. Then equals to 0. So if you should tidy this up, we are having only 30 I1. So that will be 30 I1. So we are having 30 I2 minus 10 I2 minus 30 I2. So that's minus 70. So minus 70 I2 equals to minus 20. So this is our equation 2. Okay, so now we can go ahead and solve equation 1 and 2 simultaneously. So solving equation 1 and 2 simultaneously. So if you should do that correctly, you are going to be getting your I1 to be equals to, okay, let me first of all write out the two equations. Okay, I think you can just, this is our equation 1, and this is our equation 2. Exactly. So with that now, if you do that correctly, you are going to get your I1 to be equals to minus 0.24 amperes, and then your I2 will be 0.18 amperes. Are we clear? So again, like I said, I didn't show the simultaneous part of it. I want to believe that if you're watching this video, you won't have too much problem, especially if you have watched the example 1. In one of the example, I showed you the working. Exactly. I'm just trying to save our time. I don't want the video to be just too long. But if you're answering the question in class or in exam, please show the workings. Okay. All right. So we've gotten our I1 and our I2. Again, for us to get the current that is flowing through AB, the point AB again. So we are going to look at I1 and I2. Which one has a more higher value? Exactly. So this time around, if you look at it, 0.18 is higher than minus 0.24. So this time around is going to be I2 minus I1. Remember I said something like that. If you look at the previous example we did, example 1, and in this example, when we are considering one of the sources, it has always been I1 minus I2, but now we are having I2 minus I1. So again, it is not always I1 minus I2. It can change. So that's why I said you need to understand the process. So I2 minus I1, that will be 0.18 minus 0.24. So if you should do that, this will be giving us 0.42 amperes. So now that we've gotten 0.42 amperes, and then don't forget to all indicate the direction. Exactly. So the direction will be that of I2. Exactly, because the I2 is the more dominant value, the higher value. So you indicate it. So now we've gotten the current that is flowing through that branch AB due to individual voltage source. So that means the current through AB due to the 30 volts source, we've gotten that to be 0.37 amperes, and this is the direction. For that of the 20 volt source, we've gotten it to be 0.42 amperes in the upward direction. Okay, so now how do we now get the equivalent current that is flowing through that branch? Now let's go back to the circuit. So like you can see here, if you look at it, that we already have one voltage source flowing in the upward direction, which is 0.42 amperes, and then another one in the downward. So for us to get the exact value now is for us to now subtract now the higher value minus the lower value. Just understand that concept in terms of the current with the higher value minus that of the lower value. So if we should scroll down, so that will be 0.42 amperes minus 0.37 amperes. Exactly. And with that, we'll be having 0.05 amperes. Also indicates the direction. Exactly. That means in the upward direction. So that means this will be the current that will be flowing through that branch AB. And how do you determine this direction? Because this is it, the one of 0.24, which is the one of the higher value. That's the one that's going to be more dominant. Exactly. So I hope you understand the concept. I hope you get it all clear. If you do, please let me know. Give the video a thumbs up. And if you look at this example, it's pretty much straightforward. In case you didn't just get it at first watch, try and watch maybe the second time or the third time. I believe you get the concept. Exactly. Just know that when you are doing superposition, you consider one source at a time. If you look at the two examples we've done now, we've only looked at voltage source. And like I said, if it is a current source, what you're going to do is you're going to open circuit where that particular current source is. Exactly. So don't worry, we are going to look at another example on that. So with this, guys, I'll see you all in the next video. And please don't forget, if you're here to subscribe, please click on that subscribe button to subscribe to the channel, show some love. And that is it for this particular video. Thank you.